All right, Colts, welcome back to Readiness Assessment 6, Part 2. We're going to do numbers 12 through 18. So number 12, starting off, we're going to use this word range. What is the range of the function shown in the graph? So if you remember, we have that word domain, and we have that word range. So you got to remember which letter goes with which. Does X go with domain, or does X go with range? And remember, we talked about it alphabetically. D comes before R, and X comes before Y. So Y is going to go with our range. So right now with our multiple choice, we're trying to find the range. So I can go down and I can say it's not going to be A, and it's not going to be C. So I want to know, how low does this graph go to how high does this graph go? Okay, so in this case, we have 0 and 40 for both of them, but because this line is going to be continuous, it's also going to include 0 and 40. So we're going to end up with B. Okay, moving on to number 13. It says the first term in an arithmetic sequence, A1 is going to be 2, and then A3 is going to be 6. And says which of the following formulas could be the formula for this sequence. And so if my first term is 2 and my third term is 6, we say, well, what would my second term be? Well, in this case, we would say it's 4, right? It goes up by 2 every time. Or we would take this term and we would times it by 2. So just like that as an A. So we're going to get A as an option. But it says select all that apply. So that means we're going to have more than one. So a good way to do this is if you plug in the number 1 for n, you should get 2 that comes out. So if in this one, if you did 2 times 1 plus 2, we get 4. That one's not going to work. This one, if you did 1 plus 2, that would give us 3. That also doesn't work. And in this one, it says a to the n minus 1 plus 2. So it looks kind of scary. But if our n, again, was 1, so we're going to plug in here. So we're going to say a to the 1 minus 1 plus 2. Well, if we saw that it was going up by 2 every time, that means our 0 term would be 0. So 0 plus 2 is going to give us 2. So this one also works. Okay, number 14 is a recursive formula. We actually skipped that, and so I'm going to go ahead and not have you do number 14. And we're going to jump over to number 15. All right, number 15. So we have f of x and g of x, and we see that the slopes of them are the same. And the only thing that's different is going to be this -4 and this 2. So if we were to sketch a graph, we know one of them crosses here at 2, and we know the other one here crosses at -4. And so we say, all right, they have the same slope. So remember, if they have the same slope and they're negative, that means they're parallel. Okay, so we're going to pretend I drew some parallel lines. And we're going to say, all right, G is a translation of F 6 units down. So to help us with this one, we're going to label this one. This one's G, and this one's F, because I think we get them a little confused. So we know it's a possibility of up or down. It didn't move left or right, so we're going to get rid of B, and we're going to get rid of C. So now you just have to determine if it's up or if it's down. So we got to look at G. Where is G at? Well, in order for us to get to G, 2, 3, 4, 5, 6, we went up 6 spaces, or we're translated up 6. Okay, going to number 16. Which of these functions have a graph that is a translation of the graph f of x equals x? Select all that apply. So if I do 2 times x, does that translate it? Does that move it left, right, up, or down? And in this case, no, because it would still be at 0, just like this one starts at 0. That would just make it go steeper. If I look at B, well, this would say all of my values that I have are going to go up by 1. So yes, that means it's translated up 1 unit. If I look at C, it's going to have the same slope, but all my units are translated down 2 units. And then if I look at K, this is just going to change my slope, but it's still going to be at 0. It would just be less steep. So that one's not going to work. It would be a translation. So we get B and C for that one. Jumping down to number 17. This one might be a little bit tricky. It says, which statement describes how the y-intercept of the graph compares to the y-intercept of g of x? So if we were to graph these, I think just to help us more than anything, is we have to remember what a y-intercept is. Well, remember, it's anywhere where it touches the y-axis. So if we want something that crosses the y-axis, our value of x is what at that y-axis? Well, remember, it's at 0. So let's try these. If I did f of x equals 2 times 0 minus 1, what do I get? And then if I did g of x equals 2, absolute value 2 times 0 minus 5. So 2 times 0, it's going to give us 0. 0 minus 1 gives us negative 1. So the absolute value of negative 1 is 1. And then if I do g of x, 2 times 0 is going to give me 0 minus 5. It's going to give me the absolute value of negative 5, which is going to be 5. So now we're going to go through and look. So one of them, our g of x is at 1, 2, 3, 4, 5. This is where it crosses. And then our f of x is going to be at 1. So we look at ours, and it says, which statement describes how the y-intercepts compare? So looking at A, the y-intercept of g is 4 units above the y-intercept of f. 1, 2, 3, 4. Possibly. That one looks good. Let's look at the other ones. Y-intercept of g is 4 units below. So it helps that I label them, but g is above for sure. And then the y-intercept of g is to the right. Nope. And then the y-intercept of g is 4 units to the left. Nope. So we end up with A. It helps us to go through and solve them because we might have gotten confused thinking a negative 5 is below a negative 1, but we're doing the absolute value of it. And then our last one for 18, the graph of the function g is a translation 3 units to the right of a function f of x, absolute value of x plus 4. So if you remember from our absolute value, it doesn't shift left or right at all, and we would have an absolute value function with a vertex at 0, 4. And it says it wants it to go 3 units to the right. So we want our new vertex to be here. So let's use a different color. Okay. So we have to associate some type of 3. And we want our value for this to be 3, 4. So if you remember when we move stuff left and right, it has stuff to do with inside our absolute value bracket. So if I had a plus 3, and I plugged in my value of 3 here, well, 3 plus 3, oops, not use a highlighter, 3 plus 3 with the absolute value would give us the absolute value of 6 plus 4. And we'd end up with 6 plus 4, and that would give us 10. But we don't want 10, we want 4. Okay, so let's go through and let's try it, but instead this time, let's try a negative 3. So we're going to say, all right, I'm going to plug in a 3 this time, and I'm going to say 3 minus 3 plus 4. 3 minus 3 is going to give me 0, and I'm going to say the absolute value of 0 is 0, plus 4 gives me 4. So I plugged in 3 and 4 came out. So our equation for this function is going to be f of x is equal to the absolute value of x minus 3. Close your absolute value.